Hi, I'm Leetcode Llama. Let's solve problem 1, 2 sum, together. In this problem, we are given an array of numbers, and we need to find exactly two numbers in this array that add up to a target number. We are guaranteed that there will always be a solution in each input given. We need to return the indices of the two numbers in an array as our solution. In example 1, we can see that in this array given, 2, in index 0, and 7, in index 1, add up to the target number 9. We therefore return 0 and 1 in an array. Pause this and think about how you would solve this if you have not done so yet. Okay, let's proceed with the different ways to solve this. Our first approach is straightforward, using brute force to try out every single pair of numbers until we find our solution. Using example 1, we can start from the first number 2, and then try the different pairs 2 plus 7, 2 plus 11, 2 plus 15, etc. If we have not found our solution, we start from the second number 7, and try the next few pairs 7 plus 11 and 7 plus 15. We can stop immediately once we find the solution and return our answer, since it is guaranteed that there is exactly one solution. This is the Python code for this solution. The first for loop is to iterate through all possible values of the first number, while the second inner for loop iterates through all possible values of the second number that comes after the first number. The variables I and j are the indices of the first and second numbers respectively, and we return an array with I and j immediately when we find a solution. The time complexity of this solution is O(n) squared because we try every possible pair of numbers. The space complexity is O(1), because we are not using any additional space other than the original array. Looking at the constraints of this problem, the array can be up to a length of 10 to the power of 4. An O(n) squared solution could be too slow, as that will require a runtime of 10 to the power of 8, and usually, we try to keep the runtime of 10 to the power of 7, or smaller. Is there a better solution? Yes. What if I told you that this could be solved by sorting the array first? We can then look at the first and last number and add them up. We can use two pointers to do that. If the sum is too large, we can shift the right pointer one step to the left, so that the total sum is now smaller. On the other hand, if the sum is too small, we can shift the left pointer one step to the right, to get a larger sum. We keep shifting these pointers until we find our solution. This is the Python code for this solution. Here, we use a while loop until we find the desired sum. The positions of the left and right pointers when the while loop ends is our solution. The time complexity of this solution is O(n) log n, because that is the time usually required when using the inbuilt sorting function. This can actually be lowered to O(n) using advanced sorting techniques like bucket sort or radix sort, but that is out of the scope of this video. The while loop runs in O(n) because by shifting the two pointers until they either meet, or we find a solution, we are simply going through each number in this array at most once. The space complexity is O(1) because we are not using any additional space. This solution is faster. But the downside is that we are manipulating the original array. We can overcome this by creating a copy of this array, and sorting the new array. The downside of doing that is that the space complexity will become O(n) because we need memory to store this new array. Is there another solution without requiring any sorting? Yes. As we loop through the elements in the array, we can simply check if target minus this number has appeared previously. For example, in example 1, when we look at the number 7, we check if 9 minus 7 has appeared previously. Yes, the number 2 did appear previously. So that means we have a solution. How do we check if the number did appear previously, as fast as possible? We can use a hash map to do that, because checking if something appears in a hash map is on average O(1) time. This is the Python code for this solution. As we iterate through the elements, we first check if the target minus this element has appeared previously in our hash map. Otherwise, we store this element with its index in our hash map and move on. Keep doing this until we find a solution. The time complexity of this solution is O(n), because we are just going through this array using a single layer of for loop. You can compare this to the double-layered for loop in our first solution. The space complexity, however, is O(n) because of this additional hash map that will at most store all the elements in this array. But that is fine, because it runs much faster than our first solution, and you will see this accepted on Leetcode. Awesome, we have come to the end of problem 1. If you would like to see solutions in other languages as well, please comment below. See you in the next video.